Regents exam. Algebra 1, August 2016, problem number 21. The function f of x equals 3x squared plus 12x plus 11 can be written in vertex form as. In this problem, we need to determine which of the options is equivalent to the given quadratic function. We can figure this out in a couple of ways. We can expand and simplify each of the given options until we match the original function. If we are lucky, we can figure this out in one guess. If not, we might have to expand every single one of the expressions until we find a match. Alternatively, we can also figure this problem out by rewriting the original quadratic function into the vertex form. We accomplish this by completing the square, by making use of the quadratic and linear terms of the function. We start by grouping together the quadratic term and linear term, in this case 3x squared and 12x. Next, we factor out the coefficient of the quadratic term, in this case 3. Doing that, we obtain the following quadratic expression that has a leading coefficient of 1. Next, we need to complete the square with the terms inside the parentheses. Recall that we can complete the square by introducing a constant into the group expression so that it becomes a perfect square trinomial. This way, we will be able to factor it as a binomial squared. The constant that we need to introduce can be found by identifying the coefficient of the linear term of a quadratic expression written in standard form, in this case ax squared plus bx plus c, and dividing the coefficient of the linear term, in this case b, by 2, and squaring the result. For this problem, the linear term is 4, and we divide it by 2. We then take this result and square it. Doing that, we obtain 4. We now need to introduce this term into the group expression, making sure we also introduce the additive inverse, so that the sum reduces to 0. This way, we obtain an equivalent but modified function. Notice that if we introduce the constant 4 into the group expression, we would actually be introducing the constant 4 times 3, which is equal to 12. So we need to also introduce the additive inverse of 12 into the expression in order to maintain balance or equality. Doing that, we obtain the following. Next, we write the perfect square trinomial into its factored form, which ends up being equal to the quantity x plus 2 squared. We also need to simplify the constants. Doing that, we obtain -1. In the end, we have the vertex form of the quadratic function, in this case, 3 times the quantity x plus 2 squared minus 1. Looking at the options, we see that option 3 is a perfect match, so this is our final answer.